Hello, and welcome to Science and Sleep, where stories about the universe, planets, and Earth will take you on a journey that is both gentle and full of discovery. Let your mind gradually slow down, relax your shoulders, and allow the day to close in peace. Tonight, we will go deep into the fiery heart of the Earth, listen to the whispers of volcanoes, and explore how they have unintentionally shaped the world we live in. If you wish to join these serene journeys, don't forget to subscribe and follow. That not only ensures you won't miss the next fascinating adventures, but also gives us motivation to bring more valuable content. And stay until the end of the video, because tonight's story might change the way you see your blue planet. When we close our eyes and imagine the early Earth, we often think of a peaceful, verdant planet covered by oceans and a clear sky. But the reality was completely different. About 4.5 billion years ago, Earth was not the home we know today, but a massive sphere of fire and molten rock. Volcanoes were not rare phenomena scattered as we see in the news or movies. They were everywhere, erupting endlessly, turning the planet into a gigantic factory of fire. Try to put yourself in that scene. On the surface, vast oceans of glowing lava flowed like endless rivers of fire. The air was thick with smoke and heavy with toxic gases. The sky was dyed orange, sunlight obscured by ash columns rising higher than today's Himalayas. Thunder crackled within clouds of dust, reflecting fierce flashes on the molten ground. Life could not yet exist there, but it was in that inferno that the foundations for future life were laid. Volcanoes, which seemed to only destroy, were in fact the planet's silent architects. Each eruption released elements and compounds trapped deep within the Earth. Carbon dioxide, water vapor, nitrogen, and countless other gases surged into the atmosphere. It may sound frightening, but think carefully. That was the Earth's first breath. The atmosphere, the blanket that keeps the planet warm, shields it from radiation, and allows life to thrive, was woven from those violent eruptions. Without volcanoes, our sky might have been nothing more than a cold void, devoid of protective layers. And then came water. Today, we regard water as the symbol of life, but few know that most of the oceans originated from volcanic steam. For millions of years, constant eruptions released water vapor, which accumulated in the dense atmosphere. As the planet gradually cooled, clouds formed, and the first rains fell. Not brief showers, but storms lasting thousands, even millions of years. Rain poured onto molten ground, evaporated, and fell again, repeating until the first lakes and seas appeared. Every drop of water on this planet, from the deep blue oceans to the glass in your hand, carries the imprint of volcanoes. Beyond water and air, volcanoes also shaped the first land. As lava cooled, it solidified into basalt rock, forming the foundation of continents. Great mountains were built from layers of ash and lava accumulating over millions of years. From this newborn land, essential minerals for life were released. Fertile, nutrient-rich soil, which would later nourish forests and plains, all originated from volcanic ash. And what about life itself? Many scientists believe that volcanic vents on the ocean floor played the role of the first cradle. Their hot water surged through fissures, mixing with minerals and chemicals from deep within the earth, creating a primordial soup rich in energy. In that mixture, complex chemical reactions gradually occurred, paving the way for the very first primitive cells. It can be said that life not only survived thanks to volcanoes, but was in fact their accidental gift. However, the role of volcanoes did not end in the distant past. Even today, they remain an inseparable part of the planet's rhythm. Think of Hawaii, Iceland, or Japan, lands formed entirely by volcanoes. Without eruptions, there would be no beautiful islands, no fertile soils where agriculture flourishes. Even human civilization, when you think about it, owes much to volcanoes, from fertile farmlands to the rare minerals mined from volcanic rocks. But perhaps what makes volcanoes most special is their duality of destruction and creation. An eruption can wipe out an entire city, but it can also give rise to new lands, which centuries later become human settlements. This is the beautiful paradox of nature. Within destruction always lies creation. Volcanoes are like Earth's eccentric artists, never satisfied, always breaking and remaking, but the result is a vibrant planet full of potential. If you stood on the early Earth and observed, you would see only chaos, lava, ash, storms. But if you looked from the perspective of billions of years, you would see a symphony. explosions, flows, rains, all merging to create a world capable of sustaining life. That story reminds us that sometimes the very forces we fear most are the foundations of everything most precious we have today. If the ocean is the cradle of life, then volcanoes are the silent hands that filled that cradle. We often remember volcanoes for their destruction, colossal columns of ash, rivers of glowing lava swallowing villages, or the roaring echoes that make the ground tremble. But on the scale of billions of years, those eruptions were in fact the engines that rebuilt the planet. Each time fire burst forth from the Earth's core, a new chapter was written for Earth. When streams of lava met the primordial seas, they not only formed new islands, but also released a rich mineralogy. Magnesium, calcium, sodium, and iron dissolved, mixing into the ocean, creating a complex solution, the first chemical foundation of life. Imagine this. Every drop of water you see today once passed through a natural laboratory, where volcanoes were the alchemists and the ocean was the great cauldron. In the cold, dark depths, hydrothermal vents still operate day and night. Water, heated to boiling, carried metals and rare gases and spewed them into the darkness. These superheated streams created chemical oases, where the first organic molecules may have connected with one another. It is hard not to see poetry in this. From a place of darkness, heat, and seeming death, the seeds of life were sown. Like the ocean, our atmosphere is also an indirect gift from volcanoes. When the planet was young, Earth had no air to breathe, no gentle blue sky above. Instead, there was only the cold vacuum of space. It was the first eruptions that breathed life into this world. Carbon dioxide, nitrogen, methane, water vapor, wave after wave escaped, wrapping the surface in a colossal blanket of gases. Today, we may think of them as toxic, but back then they were essential. Without that gaseous blanket, Earth would have frozen into an icy sphere under the faint light of the young sun. In the chaos of gases and lightning, chemical reactions occurred ceaselessly. Ultraviolet rays from the sun struck atmospheric molecules, triggering reactions that formed primitive organic compounds. Carbon chains and nitrogen-bearing molecules began to assemble into more complex structures. Some scientists believe that in this chemical storm, the first amino acids, the foundation of life, were formed. It was as if the sky and ocean, fire and water, together wrote the opening pages of the book of biology. It is strange to think that every breath of nitrogen we inhale today, every drop of water we drink, is a direct legacy of violent eruptions billions of years ago. Volcanoes never intended to create a world friendly to life. They simply did what nature compelled them to do: release pressure, erupt, exhale. But in that unintended process, the planet gradually became habitable. Gradually, as rains poured down, carbon dioxide in the air was drawn into the ocean, reacting with rock to form carbonate sediments. In this way, the climate was stabilized, prevented from overheating. Greenhouse gases and rainwater, both direct products of volcanic breath, together kept Earth within the habitable zone. This is a beautiful paradox. The very forces that once sowed chaos also laid the foundation for balance. Try to imagine looking at the early Earth from space. You would see a seething sphere, shrouded in ash clouds and a dense atmosphere. Amid those clouds, faint sunlight reflected off expanding seas, while fiery volcanic fissures carved glowing lines across the surface. The scene might evoke an image of hell, yet within that hell, a chemical miracle was being seeded. We can call this a lesson in humility. Humanity often views volcanoes with fear, and with good reason. But without them, there would be no oceans covering two-thirds of the planet, no atmosphere to hold warmth and shield life, no chemical beginnings. There would be no green forests, no oceans teeming with life, no us. When we understand this, we see every eruption today, though destructive in the short term, as a reminder of our origins. It is not only a natural disaster, but also a continuation of the legacy that built our world. The fire of volcanoes, once seen as a symbol of destruction, is in fact the beginning of life. And in the opposition between fire and water, chaos and balance, we find a simple truth. This world was built from contradictions. Beneath the waves, far from sunlight and the familiar world of the shore, lies a kingdom of hidden fire. Many people imagine volcanoes as massive peaks erupting on land, but in reality, most of Earth's volcanic activity occurs on the ocean floor. Along underwater mountain ranges stretching tens of thousands of kilometers, molten rock continuously rises from diverging tectonic plates. Every year, billions of tons of lava pour out, creating new oceanic crust. The world beneath the sea is a silent factory, building the planet in ways few ever witness. This formation is not just an architecture of rock. Each time lava meets seawater, a burst of reactions takes place. Steam and mineral gases are released, seeping into the ocean and turning it into a vast chemical reservoir. Hydrothermal vents, natural chimneys on the deep seafloor, spew superheated water rich in iron, copper, zinc, and a long list of trace elements. At first glance, it is a harsh environment. Darkness, crushing pressure, and water near 400 degrees Celsius. Yet it is precisely here that the first chemical oases formed, providing the energy and raw materials for primitive life. In these plumes, fire and water do not oppose each other, but become allies. Minerals precipitate around the vents, creating majestic structures like underwater castles. On their surfaces, chemical reactions are catalyzed, giving rise to complex organic molecules. Some scientists believe this is where the first self-replicating molecular chains were born. If so, then volcanic vents not only granted Earth its oceans, but may also have been the cradle of life. Life in the deep sea is truly different. Without sunlight for photosynthesis, organisms here learn to draw energy directly from chemicals, a process called chemosynthesis. Bacteria absorb hydrogen sulfide, iron, or methane and transform them into energy to sustain existence. Remarkably, this is one of the oldest forms of life, and even today, ecosystems around hydrothermal vents continue to thrive, independent of the sun. This shows that volcanoes not only created the initial conditions, but also sustain parallel worlds, where life demonstrates extraordinary adaptability. Beyond supplying energy and elements, volcanoes also shaped the entire structure of the planet. The colossal underwater mountain ranges stretching across the oceans are Earth's backbone. They divide the seas into basins and generate complex current systems. Seawater circulates through the hot crust, dissolves minerals, and returns like a gigantic circulatory system. Thanks to this, the ocean is not a stagnant body of water, but a dynamic system constantly renewed. There is an intriguing irony. Where we might think fire would be completely extinguished, it actually reigns most powerfully. The deep seafloor, seemingly the realm of water, is where volcanic activity is most intense. It is here that Earth exhales most of its heat, stirring ocean currents and helping stabilize the global climate. This silent activity has lasted billions of years, gradually shaping the living environment. This opens another perspective. If life could begin at hydrothermal vents on Earth's ocean floor, then perhaps it could also arise on other worlds in the solar system. On icy moons like Jupiter's Europa or Saturn's Enceladus, scientists have found signs of subsurface oceans along with the possibility of hydrothermal activity. If similar conditions once nurtured life on Earth, then nothing prevents it from happening elsewhere. Once again, volcanoes, often seen as symbols of destruction, may be the key that unlocks the universe. It is astonishing to think that from fiery mountains hidden beneath the ocean floor, an entire story of life could begin. Volcanoes do not just shape landscapes, they shape Earth's destiny. Every plume of smoke rising from the seafloor is a small chapter in the epic of evolution, where fire and water unite into something greater than both. Today, when scientists send autonomous submarines to the ocean depths, they are not just studying geology, they are searching for traces of our very origins. Every mineral sample collected, every microorganism found around a vent is a piece of the grand puzzle, the story of how Earth transformed from a fiery planet into a green, life-filled home. And at the center of that story, volcanoes remain the silent storytellers, reminding us that life and destruction are not separate, but two intertwined notes in the symphony of the planet. Volcanoes, giant fire machines, not only bring about the formation of islands and continents, but also carve out vast plateaus and plains. In some places, instead of rising into mountains, lava flows out like a massive ocean of fire, accumulating into flat basalt layers that cover hundreds of thousands of square kilometers. These plateaus are traces of violent eruptions in the past, when the earth and sky nearly split apart and lava rose endlessly. The Deccan Plateau in India or the Columbia Plateau in North America are still existing evidence today. They remind us that there were times when Earth did not erupt in single mountains, but poured out entire seas of fire that swallowed every landscape. Yet it is precisely these curtains of lava that serve as solid foundations for future lands. On that cooled rock, soil gradually weathered, with wind and water contributing to erosion, turning the hard basalt surfaces into fertile land. Many of those places have become prosperous plains, nurturing ancient civilizations. Fire, once again, left a seemingly opposite gift, from the initial explosive destruction to the later abundance that sustains life. Beyond forming continents and plateaus, volcanoes also contribute to weaving the intricate outlines of coastlines. When lava meets the ocean, it cools suddenly, breaking into bizarre black rocks. Over time, waves continuously strike, shaping steep cliffs, winding caves, and stone arches that seem sculpted by the hand of a giant artist. If you ever set foot in Iceland, Hawaii, or the Canary Islands, you will see this imprint clearly. Every coastal rock formation tells the story of a powerful encounter between fire and water. But perhaps the most silent and long-lasting contribution of volcanoes is the way they participate in the cycle of elements. When they erupt, not only rocks and lava are released, but also greenhouse gases, steam, and minerals. These substances do not remain still. They circulate through the air, dissolve into the oceans, seep into the soil, and then return to the crust. Thanks to this, our planet does not fall into a state of chemical freezing, but is constantly regenerated and renewed. Without the volcanic cycle, Earth might have become a dead world, like Mars, silent, barren, and devoid of the drive to change. Volcanoes are also the persistent architects of biodiversity. Wherever they appear, life often arises in unexpected ways. A new island emerging from the sea is at first completely lifeless, only rock, ash, and lava. But then, the wind brings seeds, birds bring fertilizer, waves bring algae. Bit by bit, life takes root, multiplies, and creates a new ecosystem. The Galapagos Islands, the cradle of inspiration for Darwin, are the direct result of volcanic activity. There, volcanoes not only build landscapes, but also create a stage where evolution can experiment, innovate, and reshape life. This leads us to a deeper realization. Volcanoes not only shape the material world, but also influence human imagination and knowledge. Ancient people once looked at volcanoes and thought of angry gods, of fire deities ruling within the earth. The Greek myths of Hephaestus or the Hawaiian goddess Pele all stemmed from awe of lava's power. But as science matured, volcanoes became natural laboratories, helping us understand our planet more deeply. They teach us about plate tectonics, about the carbon cycle, about the beginnings of the atmosphere, and even about the possibility of life in distant places of the universe. Not stopping at Earth, the role of volcanoes also opens up a cosmic vision. Other rocky planets, Mars, Venus, even the icy moons of Jupiter and Saturn, all bear the marks of volcanic activity. On Mars, Olympus Mons, 3 times taller than Everest, is evidence of a world once bursting with geological vitality. On Jupiter's moon Io, volcanoes are still active today, spewing sulfur lava in a fierce display. On Europa or Enceladus, volcanic activity beneath the ice may create warm oceans, nurturing the possibility of extraterrestrial life. Through that lens, each eruption on Earth today is not only a geological phenomenon, but also a doorway connecting us to the ancient past and to distant possibilities in the future. Each layer of lava piled upon another is a diary page left by the planet, telling of eras of upheaval and creation. It is easy to see only destruction in an eruption, houses buried in ash, fields covered by lava. But if we look deeper, we see another story, the story of patience, of rebirth, and of how this planet, through its fire, has given us land, air, and life. Volcanoes are living proof that destruction and creation, chaos and order, always go hand in hand. They are the fiery heartbeat of Earth, sometimes fierce, sometimes quiet, but never ceasing to beat. If fertile land is the most visible gift, then the role of volcanoes in climate and the atmosphere is a hidden treasure rarely recognized. Each eruption releases billions of tons of gases, water vapor, carbon dioxide, sulfur dioxide, and many other compounds. Water vapor contributes to the formation of clouds. Carbon dioxide participates in the natural greenhouse cycle, while sulfur dioxide can form a thin haze in the stratosphere, reflecting sunlight and cooling the globe. Thanks to the strange balance among these elements, Earth has not fallen into a state of eternal freezing or scorching heat like other planets. This may sound abstract, but in reality, the entire air we breathe today was once the product of primordial volcanoes. When the planet was young, there were no oceans, no green forests, only rains of lava and a sky full of toxic gases. It was through hundreds of millions of years of continuous eruptions that volcanoes released enough water vapor to condense into oceans, enough carbon gases to create an atmosphere, and enough elements to nourish the first seeds of life. In a very profound sense, every breath we take is a remnant trace of those ancient volcanoes. But their role does not stop at creating the atmosphere. Volcanoes also have the ability to reset the climate balance. A massive eruption, like Krakatoa in 1883 or Pinatubo in 1991, can lower global temperatures for several years. The sky is covered, the sun dimmed, and crops around the world are affected. Such disturbances, though causing temporary difficulties for humans, remind us that our planet is alive and always self-regulating. Like an invisible conductor, volcanoes sometimes raise, sometimes lower the rhythm of temperature, ensuring that Earth does not stray from the path of life. In the long history of living beings, there have been moments when volcanoes became reshapers of evolution. Gigantic eruptions in the past contributed to mass extinctions. When lava and toxic gases covered the sky, many species could not survive. But at the same time, those upheavals opened opportunities for new species to rise, adapt, and replace. Without those rages from the depths, life might have taken an entirely different path, and we, humans, might never have appeared. In this harsh paradox, volcanoes acted as strict editors of the book of life, erasing some old chapters to write new ones. The impact of volcanoes goes beyond geology and biology, reaching into human culture and spirituality. From Polynesian tribes telling of the goddess Pele dwelling in Hawaii's volcanoes, to ancient Romans believing the god Vulcan forged weapons inside Etna, volcanoes have always been personified as gods both fearsome and generous. We both revere, fear, and give thanks. Even in the modern scientific age, there remains a spiritual awe when standing before a smoldering crater. It reminds us that there are forces far beyond human power, and that every civilization stands on the fiery shoulders of the planet. Especially in the era of space exploration, volcanoes have become a bridge of thought helping us understand other worlds. When probes recorded active volcanoes on Io, Jupiter's moon, scientists immediately connected them to familiar processes on Earth. When volcanic traces were found beneath the ice of Enceladus or Europa, people began to speculate about warm oceans below, places where extraterrestrial life might exist. Thus, studying volcanoes is not only studying our own planet, but also a key to expanding imagination, bringing us closer to the great question: are we alone in the universe? From all these aspects, terrain, land, climate, biology, culture, even extraterrestrial life, it can be seen that volcanoes are the lifeblood of the planet. They never truly sleep, only operate to their own rhythm, too slow for a human lifetime, but incredibly persistent in geological time. Every mountain peak, every continent, every mineral river records that pulse. Volcanoes are nature's patience, always quietly recreating the world even when we see only outward chaos. And perhaps the most precious lesson volcanoes teach us is the lesson of cycles. Destruction is never the end, but the beginning of another form of life, another form of landscape, another form of opportunity. We often see only loss in the ash and lava, but if we look further, it is the seed for new growth. In the fierce heat, there is the patience of rebirth. In collapse, there is the potential to rebuild. Volcanoes remind us that the planet, and even our own lives, are always rewritten from the balance between ending and beginning. When we look at the surface of the planet, it is easy to forget that beneath that fragile crust lies a vast ocean of magma, always in motion. Volcanoes are pressure valves, opening to let the planet breathe. Sometimes that breath is as gentle as blue smoke rising from a small crater, but sometimes it explodes violently, creating events that can change the entire course of life. The colossal eruptions, rare but unimaginably powerful, are the silent milestones in Earth's history. They are called supervolcanoes. Unlike the familiar conical mountains, they often hide in the form of vast calderas, like giant scars on the planet's face. When enough energy accumulates, a supereruption can release thousands of cubic kilometers of lava and ash, far surpassing any eruption humanity has ever witnessed. Imagine that scene. The sky darkened for years, sunlight barely filtering through a thick veil of ash, the global climate plunging into an artificial winter. For living creatures, it is a test of survival. For the planet, it is a natural reset, as if Earth pressed the restart button to write a new chapter. One of the most remarkable events was the Toba eruption about 74,000 years ago. The calm lake we see in Indonesia today is in fact the remnant of that cataclysmic explosion. Toba hurled an immense volume of ash into the atmosphere, blocking sunlight and plunging the global climate into cold. For our human ancestors, those long, dim days may have been a wall between life and death. Some researchers believe humanity was reduced to just a few thousand surviving individuals, a harsh evolutionary bottleneck, forcing humankind to innovate and adapt to endure. Though debate continues about the extent of Toba's impact, one certainty remains. The event left a deep imprint on both the planet and our genetic lineage. But Toba was not alone. Millions of years earlier, flood basalts, such as the Siberian traps or the Deccan traps, erupted for hundreds of thousands of years, flooding the atmosphere with CO2 and sulfur dioxide. The consequences were not only climate shifts, but also mass extinctions, wiping out much of existing life and paving the way for new groups of organisms to emerge. Dinosaurs arose after the Siberian catastrophe, and they themselves disappeared following eruptions coinciding with the asteroid impact 66 million years ago. At each turning point, fire from the Earth's depths helped spin the wheel of evolution. If we look deeper, volcanoes are not just destroyers, but also sowers of the future. As lava settles, it creates new land rich in minerals. After years that seem to leave only ashes, the first green shoots rise again. The island of Surtsey off Iceland is living proof. Only a few decades after forming from a submarine eruption, that barren rock began to welcome mosses, grasses, birds, and insects, all from nothing. That is the power of rebirth, an ancient cycle that volcanoes maintain. Not only nature, but humanity too has been profoundly shaped by volcanoes. Ancient civilizations often rose around volcanic lands, from the fertile plains of Italy to the lush valleys of Central America. People relied on the soils born of lava while living under the constant fear of eruptions. Culture, faith, and mythology intertwined fear and gratitude. For Hawaiians, volcanoes are not merely natural phenomena, but the embodiment of the goddess Pele, both destructive and life-giving. In today's age, we view volcanoes through the lens of science. Geologists monitor seismic activity, measure gas emissions, and study geysers to understand what is happening deep underground. Yet alongside the analysis, there remains a sense of reverence. For each time a volcano awakens, it reminds us that this planet is larger and more full of surprises than any of our technologies. Perhaps the most captivating aspect is the paradox. Volcanoes are both the abyss of destruction and the furnace of creation. They rewrite geological history, reset the climate, drive evolution, create new land, and sometimes force humanity to change its ways. Without them, Earth might be a quiet world, and perhaps far poorer in life. So when we gaze at a volcano, whether it is Etna glowing in the Mediterranean night or a silent caldera like Yellowstone, we are facing not just a giant natural machine, but an inadvertent architect of the world. In the roaring thunder, in the columns of ash, in the fertile soil beneath our feet, all are evidence of the complex, enduring relationship between fire and life.